Good day, everyone. My name is Marian Duete La Peña. Today, this is Shop Theory in Practice 2, where we're going to talk about components and various phenomena happening in circuits, particularly AC circuit. So first, what is a resistance? Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. Resistance also actually acts like a limiter for the current in the system, because the more resistance there is, the less current flows. So next, Ohm's law. Ohm's law is a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. So if you want to get the current, the voltage, or the resistance, you will use this formula, the EIR. Next, how can you apply this in your actual installation? So in this I um I used breadboard and the components, the resistor, the LED, to um if you want to uh what do you call this, if you want to uh, get the current, the voltage, and the resistance of the circuit, you will apply Ohm's law. And using this breadboard, you have to measure them so you can get the measurement of resistance, voltage, and current. So next, what are the examples of loads, conductors, and power source? So examples of loads is include a light bulb, a resistor, and a motor. A load converts electricity into heat, light, or motion. So, and examples of conductors are copper, aluminum, brass, graphite, gold, bronze, and steel, and etc. But the main conductors is um, gold, silver, and bronze. Then an example of source is batteries, because batteries have power stored in it. So next, what are the formulas involved? So this is the formula, the VIR. If you want to get the current, you have to get the resistance, you have to get the voltage, and also it has the power if you want to get the power there. So next, sample problems and solve them. So here I have number one, we have 10 volts, and we have an unknown current and a 5 ohms resistance. So the unknown is current, so I equals V over R. So the voltage is 10 volts, divide into uh, the resistance, which is 5 ohms. So 10 divided by 5 is equals to 2 amperes, I mean. So next is in number 2, we have the 16 volts, and we have the current of 2 amperes, and we have an unknown of a resistance, so we use the R equals V over I. So we have the voltage of 16 volts and the current of 2 amperes. So 16 over 2 is equals to 8. So, and the number 3, voltage is unknown, current is given, which is 8 ampere, and the resistance is 4 ohms. So we use the V equals I times R. Current times resistance equals to 8 amperes times the 4 ohms, for So it goes to 32 volts. So next, how the setup looks in actual installation. So here, um, um, also I use breadboard because this is the simplest up, uh, tool to apply uh, circuit, especially uh, if you have if you're only in your house and you want to do circuits and you want to solve problems about ohms law. I have here the resistance, I mean the components of resistor. uh, Next is, what is magnetism? Magnetism is the class of physical attributes that are mediated by magnetic fields, electric currents, and the magnetic moments of elementary particles give to rise a magnetic field which acts on the other currents and magnetic moments. So, what is a magnetic circuit? Uh, a magnetic circuit is made up of one or more closed-loop paths containing a magnetic flux. The flux is usually generated by permanent magnets or electromagnets and confined to the path by magnetic cores consisting of ferromagnetic materials like iron, although there may be air gaps or other materials in the path. So, um, so even if air or other materials are there, as long as it's not made of something like iron or any other ferromagnetic materials, it will not change the system or the magnetic circuit, or will not affect the magnetic circuit. Yeah. Theories. What are the theories related to magnetism? So, if theories of magnetism is, if a magnetic piece of steel rod is cut into smaller pieces, each piece is a magnet with an N or a S poles on north and south. Therefore, a magnet can be said to be made of lots of tiny magnets with their end poles pointing in the same direction. So, how is magnetism related to electricity? Electricity and magnetism are closely related to each other. The electric current flowing through the wire produces a circular magnetic field outside the wire. The direction, clockwise or counterclockwise, of this magnetic field is depends on the direction of the electric current. So, and also electricity and magnetism are closely related because flowing electrons produce a magnetic field and spinning magnets cause an electric current to flow. Electromagnetism is the interaction of these two important forces. Sample of magnetic circuit. So this is my sample row of um, magnetic circuit, which has the current. We have all of 5 turns and the material given. So next is formulas of magnetism. So this is the formula of magnetism. This is too many to discuss, and uh, this I will just enlarge it so you can see, because I can't discuss them all. So sample problems and solve them. So this is my sample problems. We have the uh, oil. So L this problem actually asks how many turns are there in the uh, question. So you have this formula, L is equals to n squared over r squared r uh, yeah rg, because 12 times 10 to the power of negative 3 mh. So n equals to square root of 12 times 10 to the power of negative 3 times 1.017 times 10 to the power of 6. So it equals to 110.47, or n is equals to 110 turns. So how the setup looks in actual application. So this actually just a simple application of the electromagnetism, which the magnet alone powers the light, the bulb. So what is induction? Induction in electricity and magnetism, common name for three distinct phenomena. Electromagnetic induction is the production of an electromotive force, or EMF, in a conductor as a result of a changing magnetic field about a conductor, and is most important of the three phenomena. So theories related to induction. This is a theory for Faraday's law of induction, Lenz's law, Maxwell-Faraday's equation. So how does it related to electricity? Electromagnetic or mag- electromagnetic or magnetic induction is the production of an electromotive force across an electrical conductor in a changing magnetic field. And also, electromagnetic induction is the creation of an electromotive force by way of a moving magnetic field around an electric conductor, and conversely, the creation of current by moving an electric conductor through a static magnetic field. So samples circuits within the active components. So this is the sample with inductive components. So there, as a volt power source, the current is flowing a switch, and the um inductor component. So, so formulas involved for inductance. So here is the formula involved for inductance. So uh, there I will just enlarge it to stand. So next is um solve problems. Compute the equivalent resistance and inductors of 5H plus 2H and 7H are linked in series. So you have to get what the known values are, which is the 5H, L1, and the L2 is 2H, and the L3 is 7H. The series inductance is uh, articulated as is equivalent to 1 plus 2 plus L3. So you have to plus it. So 5H plus 2H plus 7H is equals to 14H. So induction, how the setup looks in actual application. So here I'll use some pictures. It's a quite complicated example, but this is a construction of a three-phase induction motor, especially this in the right side. That it has those induction inductive components in there. A normal motor has that. So here it has the inductive components in it. Sorry. So next is capacitance. Capacitance is the ability of a component or circuit to collect and store energy in the form of an electrical charge. Capacitors are energy storing devices available in many sizes and shapes. It consists of two plates of conducting material, usually a thin metal, sandwiched between an insulator made of ceramic, film, glass, or other materials, even air. So, sample circuits with capacitive components. So, here we have the supply of 15 volts, the switch, the resistor, which is kilo ohms, and the capacitor of 100 microfarad. So, formulas involved for capacitance. So, this is formulas involved for capacitance. In a in a circuit, so a series is the product has a different laws for that equations. So next, sample problems and solve them. So I made easy problem. I choose an easy problem. Determine the amount of charge stored in either plate of a capacitor 4 times 10 to the power of negative 6 farad when connected across a 12-volt battery. So we have the formula of C over C, so Q over V. So 10 4 times 10 to the power of negative 6 is equals to Q over 12. So the Q is unknown, so we have the answer of 48 times 10 to the negative 6 capacitance. So 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 here how does it upload in the actual application. I actually just use one of the most uses for capacitors when they are used, especially in motherboards. They found in motherboards and computer, laptops, TVs, and amplifiers, and etc. So, what is the effect of resistance and inductance, capacitance, and impedance in AC circuits? So, for me, for what I search is the combined effects of resistance, inductive reactance, and um, capacitive reactance make up the total opposition to current flow in AC circuit. This total opposition is called impedance and is represented by the letter Z. The unit for the measurement of impedance is the ohm. And also one of the main differences between resistors, capacitors, and inductors in AC circuits is in what happens with the electrical energy. With resistors, power is simply dissipated as heat. In a capacitor, no energy is lost because the capacitor alternately stores charge and then gives it back. So that's all. Thank you.